a research and policy informed discussion focused on the cross-curricular issues within maths and science. During this presentation, I am going to explore a number of areas surrounding the cross-curricular links between maths and science. What is cross-curricular learning? The history, how cross-curricular can be used to support learning, the advantages and disadvantages of cross-curricular, why teach maths and science in a cross-curricular way, linking measurement to both maths and science, the benefits and issues of using ICT in the curriculum, and the conclusion. What does cross-curricular mean? Kelly and Steed 2013 stated that links made between subjects help children to make sense of their learning because knowledge and skills learned in one subject are used to reinforce and support learning in other subjects. Cross-curricular can also be described using terms such as topic work, integrated learning, and project-based learning. Looking at how teachers viewed cross-curricular learning, some stated that it is picking up skills and knowledge from one area of the curriculum and being able to transfer that to another aspect of the curriculum. Other teachers see it as the future of education. Some teachers see it as dangerous due to the fact the content of a lesson can be lost, but majority would agree that it allows for real-world learning. I'm going to look back to where cross-curricular learning first began. In 1931, the Haddo Report looked at and endorsed the view of cross-curricular learning. The Plowden Report in 1967 encouraged teachers to explore the curriculum, and Plowden believed that the heart of education was the child. The Three Wise Men Report in 1992 by Alexander Rose and Woodhead criticised cross-curricular learning as there is evidence of falling standards in important aspects of literacy and numeracy, and they feel more emphasis should be on the subjects of the national curriculum. The National Curriculum for England 2000 focused on a programme for study for individual subjects, which resulted in a move towards discrete teaching in primary schools. A 10-year research policy between 1997 and 2007 carried out by Boyle and Bragg stated that cross-curricular teaching was still being taught during this period of time. Discrete subject teaching reached a peak on the following of an introduction of numeracy and literacy strategies, which resulted in schools reintroducing cross-curricular teaching to allow for a broad and balanced curriculum. The new national curriculum in 2014 highlights that teachers should teach subject knowledge how they feel best fits the needs of their class. Teachers should decide what to teach and what best suits them, and today in schools there are still subjects being taught individually, but there is a greater scope for a lot of subjects to be taught in a cross-curricular way. In 2009, Jim Rose carried out a review of the primary curriculum and submitted a report called the Rhodes Review. The Rhodes Review highlighted that teachers needed to be encouraged to make more links between subjects to allow for real-world learning. It also stated that cross-curricular learning can support learning in many ways as knowledge from one subject can be used in others. This meant that it allowed for each subject area to be strengthened and enriched. Not only that, but in his report, Rose stated that subjects with similar links should be grouped together in order to reduce the content of the national curriculum. An Ofsted report carried out in 2010 recognised the importance of creative learning of individual subjects through a cross-curricular approach. It stated that cross-curricular has a positive impact on the pupil's attainment and personal development. Not only that, but it allows for a broad and flexible framework. The independent review of primary curriculum in 2009 highlighted the importance of discrete and cross-curricular teaching. It stated that children should be given lots of opportunities to use and apply their developing subject knowledge, their skills, and their understanding of cross-curricular studies. This shows that the best learning experience for children would be a mixture of both cross-curricular and discrete subject teaching. Furthermore, the Rhodes Review also highlighted that our primary schools also show that high standards are best secured when essential knowledge and skills are earned both through direct, high-quality teaching and also through its contents being applied and used in cross-curricular studies. As ideas are constantly changing in relation to learning, those who are normally in favour of cross-curricular learning will use a constructivist approach. Learning is seen as an active process based on experience, prior knowledge and new ideas. Work carried out by Bruner 1968 and Vygotsky 1978 suggests that learning is a collaboration between the learner and the teacher. Bruner 1968 furthers this by stating that in order for a child to progress, a child must actively take part in a learning process for that skill to be acquired. Another theorist that supports this is Piaget 1953. His work looks at how children must be an active participant in that process in order for the knowledge to be adapted into real life content. There are many advantages of cross-curricular learning. Stinson 2009 states that there is increased opportunities for problem solving and greater knowledge retention. Boyle and Bragg 2008 found that developing cross-curricular links allowed for a broad and enhanced curriculum. Not only that, but if lessons are more cross-curricular based, it will allow for a more positive impact on students' attitudes and interests within school. Further to the point, the fact that there is always links available to use between subjects means that it allows for a real-world learning environment. On the other hand, the disadvantages can be seen that subjects lose their identity. This is because teachers try to use cross-curricular learning objectives just so that links are made, but these links are seen as unnatural. Greenwood 2013 carried out work which stated that teachers have a fear on how to deliver a high-quality cross-curricular lesson, because they feel that they are losing out on the focus of that lesson. Planning for a cross-curricular lesson can also be time-consuming, which results in content being rushed and not as high a quality lesson being delivered. Assessment areas then become unfocused as the scope for learning is too broad, as there is a loss of specific content during the lesson. Finally, it can be seen as risky and challenging to be able to deliver an engaging and high quality lesson while ensuring to have a broad cross-curricular approach. Maths and science are difficult subjects to grasp, and basic knowledge of these subjects need to be taught first before they can be taught together. A report carried out by Ofsted in 2002 noted that one of the features of successful primary schools is the ability of teachers to plan opportunities for children to apply the knowledge and skills learned in one subject and use these in another subject. This can be backed up by Barnes in 2011, as it stated that maths is a subject that can have many links to many other subjects. Furthermore, Haylock and Tangata 2007 stated that it is difficult to do much science without using some aspect of maths. In 2014, the national curriculum stated that measurement is a key area in both the maths and science. When looking at maths in the national curriculum, it states that teachers should use every relevant subject to develop pupils' mathematical fluency, which would suggest that in order to develop mastery of maths should be taught in every subject in the national curriculum. The national curriculum also states that children should also apply mathematical knowledge to their understanding of science, which would suggest that maths and science should be taught in a cross-curricular way of learning. There are many activities that children could do with measurement in both Key Stage 1 and Key Stage 2. Within Key Stage 1, measurement is carried out as a non-standard method. So an idea of a lesson within maths would be that children go around the classroom and measure different objects using their hands as the unit of measurement, and record this in a table format. And an idea of a science lesson would be that the children can use the playground to draw a line in chalk to measure the length of a person's shadow at different stages within the day. Within Key Stage 2 maths, children need to be aware of the differences between mass and weight, volume and capacity, distance, height and time. Therefore, they can compare and contrast the differences in these and the units of measurement required for each. An example of a science lesson would be that the children measure the rate of growth of a seedling, which would require them to measure the height grown over a period of time and record these results in a table format. Our world is changing rapidly through the use of ICT. There's becoming increasingly more ICT being used in the classrooms than ever before, with the use of interactive whiteboards, iPads and laptops, which are being used as ways of teaching and learning. The new national curriculum seen that this was going on in a classroom environment, and therefore has highlighted opportunities for the use of ICT in teaching. Ofsted 2009 backs this statement up by stating that ICT is fundamental to engagement within society. ICT can be useful to encourage children to be independent learners due to the fact of having the internet and search engines It allows children to check information for themselves without having to ask the teacher for help. Not only that, but it can also help children to be more engaged in activities. Using ICT within the classroom learning environment can increase a child's confidence and motivation, but can also help the children in completing tasks, as ICT can help the children to record data, find and store information. There is a constant need for teachers to learn new skills when working with ICT, as it always is a developing industry. Schools may not have enough computers in order to accommodate all classes, as schools may have a shared computer room which can be booked up by another class. This is a very likely possibility. Financial problems can also affect schools, as a lot of schools do not have the funding required to deliver a high quality computer suite, or even to supply enough laptops to cover a full class. Teachers can also become too dependent on the use of ICT within a lesson. There's not enough time to use ICT in a lot of lessons, and it is counterproductive due to the insufficient technical resources. To conclude, in this presentation I have identified how maths and science are two subjects that work well together. Cross-curricular approaches are extremely beneficial within primary schools. I believe that children should use the skills from one subject and apply that knowledge to many other subjects. Using ICT is fundamental and should be used frequently in many areas of the curriculum to engage and support learning. There are many studies and theories that support cross-curricular learning. I think subjects should be taught in a cross-curricular way once children have a good foundation of each individual subject. The 2014 National Curriculum addresses the significance of implementing a cross-curricular approach to enhance learning, especially in maths and science. As teachers, we should continue to approach teaching in a cross-curricular way as proposed by the National Curriculum. Thank you for listening to my presentation.